Hello everybody, here I present my project on image-based techniques for the quantitative evaluation of patient-specific geometrical properties in coronary arteries, which I developed during my stay in Istanbul. First of all, what are coronary arteries? Coronary arteries are the blood vessels responsible for bringing oxygenated blood to the cardiac muscle, so obviously they are very important, and they can be subdivided in two major branches. The left coronary artery is LCA and the right coronary artery is RCA. In order to perform realistic numerical simulation of blood flow in coronary arteries, first of all we have to retrieve some information about the geometry and the structure of coronary arteries. So we speak a bit about surface reconstruction. We start from the analysis of the right coronary arteries, RCA, and we perform an image segmentation of the right coronary artery starting from a CT scan data. CT is a computed tomography, and here we can see a cross-sectional representation of a thoracic CT scan, and we plan to put the seats near the aorta in that point, and then we follow the lumen of the blood flow in order to retrieve its final point and segment the whole branch of the right coronary artery. Here we have a first visualization of the right coronary arteries reconstructed by means of BMTK, and here is the final representation of the surface reconstructed. Then we used some image-based techniques in order to evaluate geometrical properties of the coronary arteries. In that case, we focus on the circumflex coronary artery, namely RCX, which is a branch of the left coronary artery. And here we can see the reconstructed surface using BMTK again, and the centerline representation. Centerline is a good way to represent geometrical information in vessels because, as you can understand, centerline lies in the middle of the vessel through its whole path. And we choose to analyze the circumflex coronary artery because, as you can see, it presents an interesting wave path pattern on one of the branch. First of all, we computed the Voronoi diagram, which basically is a finite dimensional approximation of the medial axis, and we use the center lines in order to construct the branch splitting. That is identifying inside a bifurcation the vessels composing the bifurcation itself in order to map them to a cylindrical mesh, which is some kind of reference mesh for our computational problem. Then we had the opportunity to compute the curvature, which basically is quantifies how much the vessel under analysis changes with respect to a straight pipe, and the tortuosity, which basically quantifies how the change in the direction of the path of the vessel influences the length of the vessel itself. Then, back to our right coronary arteries previously segmented, we can observe that in the upper part there's a bulge that under physiological conditions shouldn't be present. This is an aneurysm. This is an example of a terminal aneurysm. So we finally perform some image-based techniques to remove the aneurysm, digitally remove the aneurysm, and retrieve the original shape of the blood vessel. In particular, here we start again from the center lines, and we present the clipped center lines where we have neglected the part, the sections of the center lines which are affected by the presence of the bulge. Then we interpolate them in order to retrieve the original flow path, and we compute the corresponding Voronoi diagram. The final results for the reconstruct parent vessel is clearly satisfactory. You can observe that it's exactly what we were expecting in absence of the bulge, and here are some zooming on the final representation itself. So, in order to summarize, we used the image-based techniques in order to retrieve information about the geometry of the coronary arteries. Why did we focus on the geometry itself? Because we realized that this is the very critical step to be performed before being able to analyze the flow in the coronary arteries itself. And especially because coronary arteries with respect to other major arteries have smaller dimensions, and so we focused on this analysis in order to get more information about the physiological and pathological condition of coronary arteries. Thank you.